So before we get too deep into this, I have a couple quick announcements. The first is that, well, you all know that the 8th is on Friday, but the second study session from the ACM Club is being hosted at 2:30 again this Wednesday down in 216, one of our labs. So the feedback that I got from the first section was that was very useful for helping people prepare, feel better about their preparation for the 8th. So for those of you who didn't attend the first time, I highly recommend going to that. It should be very useful. Second, we have an assignment due on Wednesday. Our recursion assignment. Again, I tried to make that as useful as possible with regards to 8 prep. So if you have any questions about it, you'll see me during office hours either today or tomorrow. Third, this is coming from our TA. He's going to post about this on Canvas as well. But I have noticed that some people aren't submitting either the entirety of the files that are necessary for grading, or they're submitting files without an associated package structure. So if you look at Eclipse, for instance, I have all of my linked list classes under my linked list package, and then they all have this package declaration at the very top. Just make sure that if you can all copy that logic, and then all you need to zip up is this package. You don't need anything else from your project. And there's always a way to do this from every IDE. I'm in Eclipse. It's exactly the same thing that you can do in IntelliJ. You just right click, go to show in or open with. I think it's open with in, and then you go to Explorer or System Explorer, and that will grab you the working directory for that. So all I'm looking for in submissions is just this one folder. So this would be what you compress to a zip and submit to Canvas. Questions on homework submission? Yeah.
Do you take late submissions at all?
I do, kind of on a student by student basis. So if something is going on, email me, let me know what's going on. I am very likely to accept it the first time you email me, even if the exception isn't I'm in the hospital and dying. But it becomes less and less likely the more you request it throughout the quarter. So if you're requesting it for the same things and the same reasons, like I didn't get started until an hour before it was due, I'm going to be less and less likely to accept that as the quarter goes on. But still definitely reach out to me and ask me, make me say no. Other questions before we get started with today's content?
So are you going to cover I think writing in the class for another example?
Yes. Yeah, that is where we're going to start. We're going to go over that solution. So last time we introduced this new way of thinking about expressions. We're used to thinking about them in terms of what we call infix. And as we learn about stacks, we can learn how a computer might efficiently be able to handle expressions in a way that removes parentheses and order of operations completely from what we need to consider. So we got some examples of that. We looked at this example down here, 8, 6 plus 10 times, and the equivalent in infix was the quantity 8 plus 6 times 10. And we knew this because we had symbol here, the plus, that represented doing this operation on the 2 prior on the operands, and then the times is 10 times the result of this expression. So that allowed us to be able to calculate this, and we saw that we could do this with a single pass with a stack. So we're going to start back with the examples that we were going over last time. So we started with 2, 3, 4 plus times, and we saw that as we did this, this is kind of the equivalent of we took the 3 plus 4, and that became the first operation that we actually did as we were doing this. And then we saw that we took the result of that, and that gave us 7. And then we did the 2 and the 7, and so we're kind of doing this, we're working from the inside out. Like we would in infix, but we can parse this in a single pass from left to right using a stack. So again, this looked like we see a 2, we push a 2, we see a 3, we push a 3, we see a 4, we push a 4. We see the plus, this tells us to take the top 2 elements of the stack, and we're going to put them in the associated place. We started out with operations that were commutative, which meant that it didn't matter which order we did this in, but we find that when we do any operation that is not commutative, it really matters that the top element of the stack goes to the 2nd position, and the bottom element of the stack goes to the 1st position. So this 4, 3 plus basically is telling us to do 3 plus 4. We want to make sure the 4 goes into the 2nd position, the 3 goes into the 1st position. And so the resulting stack, the 2 hasn't been touched, but the result of the addition goes on top of the stack. And then we're able to do the times operation there on, we're gonna pop the 7, and that goes in the 2nd position. We're gonna pop the 2, that goes in the 1st position, it's commutative, so it doesn't matter here, but we'll find that it matters when we tackle subtraction or division. And that allows us to see the resulting value here is 14. At the very end of this process, the answer is on the stack, so you can do a peek or a pop of the stack. And that allows you to see the result of the operation, which you do when you get to the end of the expression. Once you have nothing left to read, your has next is returning nothing. There's no additional token to read. Then the answer is the only element type on the stack. Questions about the general form? Just going back over the general form. This should be reviewed from yesterday. But I'm happy to go over this in more detail if there are any confusions. Always steal the eraser. Good to erase? Okay, we got a couple more examples of this before the one that was really tricky. So we saw 2, 4 times, 3, 5 times plus. So again, if we're kind of putting parentheses around what happens, if this helps you to be able to visualize what we are doing. We first identify that we're doing 2 times 4 and 3 times 5. That gives us 2 resulting numbers, 8 and 15, that we then add. So that's just another way to think about postfix rather than just going from left to right as a stack. You can start to think of what are the associated groupings of numbers, and then what are the operations that get applied to them in what order. Then we saw this. 2, 3 minus 4 plus 5, 6, 7 times plus times. So I gave people a little bit of time to work on this, and it seemed like there were some divergent responses. So we should absolutely go over this and make sure we know exactly what the correct result is. So rather than try to do this in our heads, let's actually play the role of the computer and use stacks. I find it's much easier to make mistakes if you're doing this in your head. Whereas if you actually draw out every single operation, it is easier to get it right. So we see a 2, we push a 2. We see a 3, we push a 3. We see a minus, and this is our first operation that is not commutative. So now it is very important that we pop these into the correct place in a pseudo infix expression that we're going to evaluate. So we need to take, this represents 2 minus 3, not 3 minus 2. So we're going to pop the 3 into the second place, pop the 2 into the first place, and we see that 2 minus 3 is in fact -1. That's what's going to get pushed back to the stack. Continuing, we're going to push a 4. We reach a plus. When we reach one of these symbols, it says pop, pop, evaluate. So we are going to do that. In between this position and this position, we need to pop the 4 into the second position, pop the -1 into the first position, and add, giving us 3, which gets pushed back to the stack. We then are going to do some significant pushing. So I'm going to draw our stacks just a little bit larger. We have 3 followed by 5. We do another push. Throw the 6 on there. We have a 7, and now we have lots of operations to do. So we're going to take this 7 and the 6, and we are going to multiply. We're going to pop the 7 into the second position, the 6 into the first position. Off the top of your heads, what's 6 times 7? 42. Great. The next one we see is plus. So we're going to pop these top 2. The first one's going to go in the second position. The second one is going to go in the first position. We are going to add. What should the result be? 5 plus 42. 47. And finally, we are going to multiply. So between this and the last thing we do, we are going to pop the 47 into the second position. We are going to pop the 3 into the first position. What is 3 times 47? So we see that the result of this is 141, which is one of the answers that I heard yesterday. Does anyone have any questions about this process? How it uses a stack, how it uses the stack operations? Stacks are wonderful structures. Once you understand them for the first time, they are very intuitive and they can solve some problems very efficiently and nicely in ways that make you wonder why we've ever used infix notation and why we teach our children infix notation. All good with everything on the board? Okay, so we've already seen this. How can we use a stack to solve postfix expressions? Here is a general pseudocode. While characters remain in the postfix string, we should read character by character. We then need to branch and figure out what is that character. Is it a digit or is it a symbol of some kind? We call them operators and operands. So if it's a digit, convert it into an int, because you might be reading this, if you're reading it character by character, you might be storing it as a character or storing it as a string, in which case you'll need to convert the character into an int and push it onto the stack. If it's an operator, like plus, minus, times, divides, something of the sort, then we do the pop twice, evaluate, and push the result back onto the stack. And then we continue to do this in a loop. Once the loop is over, then the final value is on the stack. Intuitively, how do we know that a postfix expression that we have been reading is invalid? We talked about how there were some possible invalid postfix expressions. What kinds of exceptions could we throw and where in this logic to figure out that was not a valid postfix expression? Yeah,
It's on a character.
It's not a character of some
No,
kind?
It depends on the character, so there's no operator at the end to include it.
Okay, so if this ends with like a 3. So we'll know that every postfix ends in some kind of symbol. If it ends in a number, then that's not a good sign. I would argue we can generalize this to something that works for other problems as well. That's very good to notice.
You can consider it like if the final size is more than 1.
Yeah, we want to look, when we're done with this, we want to look at the stack size. If the stack size is more than 1, what happened?
Math is math.
It means we had more than, so we should end up with, if we count the number of numbers, 1, 2, 3, 4, 5, 6. When we count the number of symbols, 1, 2, 3, 4, 5. We should have 1 fewer symbol when we do numbers, which makes sense. If you think about the index notation, every symbol is working on 2 operators. I'm sorry, 2 operands. So we have like a 3 plus 5, but if the expression is more complicated than that, then we take the result of this and it becomes the left-hand side or the right-hand side of some, it's the sub-expression of some larger expression. So maybe we take this, we subtract 4, we take the result of that, and we divide by 6. But you can see how as we expand this out, there's always one more number than there is symbols, because the result of some sub-expression becomes a value that is one of the 2 that's used for the next level out. So we should expect that there is one more number than symbol. If we end up with a process that has more numbers than that, more than 1 more numbers than symbols, the end result is that the stack is going to have more than 1 element on it when you finish this process. So you can query the size when you reach the end. If the size is not 1, you have an invalid postfix expression. You also might run into an issue while you are going through the postfix expression. What would that issue be? What would allow you to not be able to continue evaluating your postfix expression? That would definitely, there are all the way associated math errors we would expect, like trying to divide by 0, absolutely. But there's a great point here that if we end up with a stack size of 0 and we need to grab something off the stack for some reason, we can't do that. So the easiest example of this is that a postfix string started with plus. Well, there's nothing on the stack for us to go grab, we can't continue. The only thing that we can conclude is that the string is not valid. So those are the 2 kinds of exceptions we should be looking for. If we're ever trying to pop from an empty stack, and if we finish evaluating and the stack size is greater than 1. All right, and now we should start to transition and think about, well, the rest of the world thinks in infix, and now that we feel alone as computer scientists in the world thinking in postfix, we'll need to be able to convert from everybody else speak to computer science speak. So we want to read input as an infix expression. It won't really work if you write a program in general that says enter an expression, and you expect your user to be able to enter it in postfix. So we need to write code to convert infix to postfix so that we can evaluate it quickly, ignoring order of operations and parentheses. So why don't we get together in groups of about 3 or 4 and see if you can figure out, given the user entering some kind of infix expression, how do you convert it so that the result is a string that is in postfix? So let's spend a little bit of time working on that. How would you do that? I do expect you to work in a group for this because it's not easy and you should put your heads together. Not literally. We're not rams. So things you're gonna need to consider before we get too started with this, things you're gonna need to consider. Infix contains parentheses. How are you going to deal with this? Infix contains order of operations. How are you going to deal with order of operations? You see 3 plus 5 times 6. And infix tells us to do the 5 times 6 before adding the 3. How are you going to deal with this? The solution to this means that you do not want to move backwards in this string. So you're not going to have some kind of pointer that's going to go back and forth between these characters and symbols. If you need a character or a symbol that you're going to be referring to later, store it for later. How are we going to store it for later? Think about the structures that we have access to. We have access to lists, and now we have access to stacks. Which one of those is going to make more sense here? Do we need to store these in a list to access them in an arbitrary order, or do we really only need access to the top element of the stack at a time? And that will inform whether you use a list or a stack for this.
Yeah.
A group that could work together somewhere in here, I see 4 people working alone, we could either see pairs of 2 in there, or a group of 3 or 4 developing maybe.
So what do we try to stack?
Maybe that would form, get out with.
We're trying to like, what do you know? Yeah. That's your album. Star. Yeah, this is not. Very good interval spot. So what's your goal? I think that's.
It's the oxygen.
Just asking questions. What do you all think? If you want. We're not really.
Somebody asked me questions.
We're still just asking questions.
Yeah.
So you think, right, you build it.
I wanna like. Where like my boss or something. That's my boss. On the bottom of the stack. And then put it up. So the top of the stack. There's a stack. New one.
So you're gonna read the string once, you're gonna build up some backstack, and then you're going to. Interesting. So what if the order of operations are in the correct order that we're seeing? So we see the time equals to the plus. If we build a stack, then the plus is gonna be in the times you gotta dig all the way down to get access to the time, because that's what you want to do first.
No, so it's like the sort of.
Conditions on the line.
Oh, no.
How do you guarantee that if you don't know what's coming? It's great from that, right?
I have a secret.
What was that, sorry? You could do a list. Then you need to go through the list and analyze places in the list, try to figure out where the order of operations is. I would argue, though, that there's something about the form of the expression that tells us what we need to do. Imagine you're parsing through it and you come upon a left parenthesis. What does that mean? It's the start of some sub-expression that needs to be evaluated before other things. So what do you do about that? The other thing to really think about is, what are we storing on the stack? What makes sense to store on the stack? Do we want to store everything that we see on the stack? Or when we run across symbols, what does symbols tell us to do? Do symbols tell us to do something immediately, or do we need to consider something about the symbol that we are reading? If we're not thinking about exponentiation at all, I would argue that let's not think about exponentiation for now. We run across a times or a divides. We know that's the highest order of operation unless we have an ongoing parentheses thing. So can we evaluate that right away or close to right away? If we come upon a plus or a minus, what's the difference? What do we need to do algorithmically to wait and try to figure out, is there a later order of operation that we need to worry about? This is where a stack would be useful. We can put something on the stack that says we can either evaluate this right now if we later determine we can evaluate it, or we later come upon something that says that this takes priority, which means that after building the stack on top of it, which case when you pop it, you have access to the higher order of operations first.
Think along those lines. So kind of what I was trying to say, but. In some ways, but. I think go ahead, I'll get into this first. Yes.
Oh, sure. Yeah. How many guys are in?
How are these groups doing?
Still processing.
Thoughts and ideas? What ideas do you have?
Right?
Still break it down. That's not what science first to do.
It's not apparent immediately. It requires some thinking. This is the kind of algorithmic thinking that computer scientists do very frequently. We have a problem, how do we solve that problem? If we don't want to solve it, we want to solve it efficiently.
Yeah.
So how do we come up with the process that allows us to do that?
You reach. Right. No, I say, because we have.
Right?
Yeah. What do you say?
No, I think that's.
Your thoughts?
Yeah.
So you have this, this is exciting.
Okay, I think I'm ready.
Yeah.
And then it's like.
There's 6 of them.
Going to a plus like that before multiplications of both.
Right. Yes. Huh?
But then again, if you run into multiplications, it's what it's not supposed to be.
Great point. So. How do you want to handle that? Yeah, that's tough.
Yeah, no, I think it's too, that's right, it needs to be on the bottom. So you didn't want that on the bottom. And then throw it. I guess you can't do it like that. 4, 5 times. Yeah, I know.
This is 2 12.
No, it's not.
I just don't feel
It's not
like I don't.
Yeah. That's not doing everything. That's sitting in my head, but yeah. I can't put it in comments.
Well, that's, and he's.
So it's like, get on the right track.
Group in the middle of the classroom that I don't have easy access to, how's it going?
I think we have a good idea of how to start, but we're still kind of in the prototyping phase. I think.
Yeah.
Yeah. So.
People need a hit.
I mean, I think that's like one perspective, you know,
Yeah.
like doing.
Yeah, right at the top of it. And
And
then.
We're trying to start, we're trying to get it.
Figure out what's at the top of, and then put that. And then here.
All right, hint time. So we see it in a fixed expression. When we see a number, do we ever need to store that from there? basically, we are always pushing these symbols backwards some number of places. So I would argue what we actually want to store are the symbols. And when we see a number, we never really need to store it for later, we can just output it. And the difficulty comes in, where do these symbols show up? What is the difference between 3, 5 plus 7 times and 3, 5, 7 plus times? Or 3, 5, 7 times plus? Or like, what are the same between these? What are different? What do the expressions mean? It's all going to be in the same order, but changes here is just where the parentheses are and where the symbols are. So think about not worrying so much about the digits. When you see one, output it. What we need to store and figure out how to deal with this is when we see a symbol, do we output it? Do we store it for later? What do we do with previous symbols that we've seen when we see a new symbol? If we haven't output the previous symbol yet.
Every time there's a number. Yes. And you go through. So if it doesn't every time it's assumed, if it doesn't. Letters stars, so we have this parentheses, or you have your own arrow. I guess you can do another plus again. So I don't do that. And then we 5 or 6, 7, right.
You have to be on the north side, right? On both sides. No, we've been right. If you're gonna how it interact with outposts. On the left hand side.
Do not those are steps we have long.
Wait, no, I mean on the right hand side.
Here's going to please. Those are steps, yeah, we're starting to see bottom.
Oh,
No, that's just, those are all.
so you would have to go through it first and just grab the those parentheses.
Yeah, I think so.
And then we'll run through it again. And then you do.
Yeah.
Multiplication. We are.
But we're still.
This is about to be there's moving.
It's like a general.
Honestly, I think
Yeah,
that's
but
bigger.
is in the middle.
I think the experience.
I know how, I know what we have to do.
Like, that's a good example.
Just top of the box, it was a little style, more than friendly than that.
Yeah,
So you can. Moving forward, you can determine. There has to be some. So you already.
You see the right.
I got it.
Yeah, but it's like, that doesn't.
Yeah.
We're still having the signs. Michael see like counts, like outside of things. Yeah. The parentheses, not too much, so we should still not try to see this by. So the times these.
Yeah, that's.
done.
those ones.
And still like login screen. So what would allow us to do that? You can also get.
You can do the thing.
I think you're on the right track.
Index problem.
Yeah. So I was thinking. How are we doing? Who wants an answer?
Give us a little more time.
Who wants more time? A few people? Let's give you a few more minutes.
Like maybe.
I think you can get there.
Oh, a lot.
Yeah.
How they are.
Broke my code.
Yeah.
I'm like, what, 5 minutes ago or something? I was like, believe it or not, I didn't know.
All right, I think we need to wrap this up to get through a solution and an example by the end of class. So hopefully people got somewhere. I don't really have the expectation that people fully finish this off, but did anyone think they have a solution? Yeah? What are your thoughts?
I didn't finish it, but what I'm thinking you do is you iterate through like the string that you wanna look at.
Yeah,
And then if the symbol doesn't equal like a parentheses or an operator, you print it out. And then if it does equal a parentheses or an operator, you check if it's a parenthesis and you push that parenthesis into a stack. And then if like if you check the stack and the parenthesis is now closed, you print out like the operator that you were like storing in another stack.
yeah, I like it. That's very, very close, actually. So let's take a look at some pseudocode that is gonna do it for us. So we're going to read symbol by symbol. That ended up massive on the screen. That's a little bit better. So while there are more symbols to be read, we're going to read symbol by symbol, and we break this down into what is that symbol. If the symbol is a number, we're just going to output it. Done, we're not going to worry about it. That was my hint. If it's a left parentheses, we want to push it onto a stack. And the reason is, we don't know if the order of operations are going to be overridden because of these parentheses. If that's the case, then we need to store that we want to potentially override the order of operations as part of these parentheses. If we find a right parentheses, we're going to pop all symbols off the stack until we pop the left parentheses, as if this was the start of the overriding of the order of operations. Obviously, we don't want to output the parentheses because postfix has no parentheses. If we see a symbol that is not a left parentheses or a right parentheses, so a plus, minus, times, divides, we will start peeking and popping from the stack all higher or equal precedence operators than the current symbol that we just found. That's the big key, is we see something that has a higher precedence that's already been done, we want to do that before we do the current thing. We see a plus and we previously had seen a times, that means we want to do the times before the plus. Let's see how this works with an example. So we want to stop before popping a lower precedence operator or left parentheses. We want to then push the operator that we just saw onto the stack. So if we see something higher precedence in the past that we needed to do, we're going to do it. The current symbol, we don't have the right-hand side for yet because it's an infix, so it needs to go on the stack until we output that right-hand side of the expression, and then we can output the operator. Makes way more sense with an example. Here's an example. We're going to read A divided by the quantity B plus C minus D. So we start with an empty stack. We read the A. Since this is something that needs to be output, it's a number in this case, whatever A happens to be, we're going to just output the A without interacting with the stack at all. We then go read the divides character. When we see the divides character, we're going to push it on the stack because obviously we don't have the right-hand side of what we're going to be dividing by yet. So we need to wait to output this until we have identified where the right-hand side ends of this sub-expression. A divided by what? In postfix, it's left-hand side, right-hand side operator. So as soon as we've identified that the right-hand side has been identified, that it's been found, then we want to output the divides. So we don't output it yet. We then see the left parenthesis. So according to our rule, we're going to push this onto the stack that says we're going to override our order of operations between this and the right parentheses whenever we see it. We then see a B. That's a symbol, we're going to output that right away. We see the plus. When we see that plus, we're going to look for higher precedence operators on the stack. The first thing we see when we peek the stack is a left parentheses. That's not a higher order operator, that's a parentheses, its own special case, its own special thing. So rather than output that, we're going to push the plus directly onto the stack. We then see the C. Once we output it directly, we see the right parentheses, which says pop everything on the stack and output it until we pop the left parentheses and don't output either the left parentheses or the right parentheses. So we don't output it, we pop from the stack, see a plus, output it. Reach the left parentheses, we're done. We go and see the minus. When we see the minus, we're going to peek at the stack and we're going to say what's on the stack that is higher precedence than this minus. The top of the stack is a divides, so that tells us to output the divides. Remember that we don't output the minus yet because again, we have not seen the right-hand side of that expression. We have a left-hand side minus some right-hand side that we haven't seen yet. So we're going to push the minus onto the stack. And then we see the D, we output the D, we see the end of file, which tells us to pop and output everything on the stack. So everything that's left on the stack is just this minus, which gets appended to the end. Question?
That divide only getting popped because it's higher precedence.
Yeah, it's higher precedence than the minus when you see the minus.
If it was plus, you would just add the minus on.
Yeah, yeah, and then the minus plus for the would be up here. Because that would be the appropriate order if this was plus D. Or if the divides was a plus instead of a divides. We would have done that at the end rather than in the middle at the beginning, because it has higher precedence, it goes more toward the middle. All right, we are definitely over time by a little over a minute. I apologize. If anyone has any questions about this, I'll have ourselves for the next hour, but I will also start the next class by going over this again and seeing if anyone has any questions about this process. I will see you tomorrow for that and introducing the Q abstract at a time.